Oh, yo. What's up, everybody? Welcome back. Today, we are making a new image editor because I can't figure out how to use GIMP to save my life. It's too hard, man. It's too hard. So instead of learning existing tools and getting good at them, what if we just threw out the existing tools and made our own? That is what we're going to do. We're going to make a new image editor. And, part of this is in tongue in cheek. I also feel like I have some ideas for something that would be more in line with what I believe an image editor should be. Right? So what I'm imagining is kind of like a image editor that is based around the idea of having an editable history that is non-lossy and is heavily based around the concept of like shaders, right? So let's start with a simple example of like a cut and paste, right? I go into my image editor and I don't know, I draw a little picture, right? Smile, right? And I want to like cut this and move it over, right? So what is actually happening here? Well, we could kind of imagine this as making a new image out of the existing image, right? We could say that like the old image has now been split into two. We have like this segment over here and this segment over here. And you could imagine that like the way you would do that is you would like maybe take like a section that was here before, right? Color it in and say anything behind this blue selection is part of the new image, and anything that's not part of that is part of the old image, right? And so you could kind of like draw this out as like a set of actions that is applied to your input image, right? You have one input image that's your smiley face, right? And maybe you like draw a selection for that thing, right? And this selection could be kind of represented as like a path, right? So like I've drawn some sort of selection of thing like shaped like this, right? And so we could say, okay, we have a path, a thing we've drawn. A mask can be constructed by this thing by basically just figuring out like what's inside this path, right? Boom. And then in order to do the cut and paste, you basically invert this mask and like apply that to one half of the image or to the image, to the whole image, right? You invert the mask, apply it to the whole image. That gets you one of the outputs, right? And you keep the uninverted mask and apply it to the other half, and that gives you the other image, right? Now you have two images, and you can like kind of slide them around, position them how you want, and then composite them back together by saying, okay, so these two images both like exist in this plane. Let's like squash them all down onto one layer and like render them, right? I think that this concept is quite powerful, in that I could go back in time. Say we represent this set of actions like this, right? First of all, if we decide to change something in the future, right, we go back in time, we edit this path, and we kind of like maybe make him a little larger, right? We go, okay, actually, we wanted this stuff as well. We haven't like lost any information. We're kind of like, we can just run the same sequence of actions on the same inputs again, which is pretty sick. And if we take this concept of like apply this mask, this mask application is really just like multiply input image by mask, right? You could kind of structure this differently such that so that like you could do a large amount of effects like this, right? The same thing that is applying this mask, for example, you could say, what if I want to like make it look like the guy's fading out? Well, I could write a GPU shader that says basically like the strength of the shader gets stronger and stronger and stronger the farther to the right we go in the image. And if you then applied this shader instead of like this mask to the input, you could kind of get like a gradient by doing that, right? Or if you wanted to do something like I draw a path as like a brushstroke, right? If I want to draw like this line, well, I could draw a path that like gets sampled like this, right? And I could maybe adjust the way that the stroke looks. I could say like, okay, well, I want a red line. That is a shader that says take find the closest distance to this path and make it red, right? I could like make it a gradient by making my shader say, as I go along this path, like go from green, progressively move from green to like more and more red as you go across or something, right? There's all sorts of like things that we could do that are all just like a stack of these like few simple primitives, right? The idea of a path, the idea of an image and the idea of a shader could all kind of be put together to do everything we've talked about so far. And I think that the only other piece here is like the idea of a transform, right? So I take this guy and I want to like rotate him, right? This could just be applied as like we have like an image on a plane, and then you kind of just go like you apply some transform to that thing, and maybe you can like link these like images together so that when you rotate one, another one rotates around it. Kind of like the I'm stealing a little bit of like Blender's scene hierarchy idea from here. So like if I have like a cube and another cube, I can like make this cube small and say I want it to be kind of like related to this object, so that when I rotate, how do I do this? I set like I click this, then this, and I click parent. If I rotate this guy now, that other cube kind of stays attached relative to the same spot. And if I like scale this guy, the other cube gets bigger. I kind of want to have like something like that where you have like a scene hierarchy of like images instead of like 3D objects, and they have like their transforms applied relative to each other, and maybe like a path is relative to an object, so that like basically I want to make it so that I go back in time, I change any of these things, and everything downstream just kind of happens for free, right? That's kind of what I'm imagining. So the plan of action for today is to just get like the bones of that thing in place, right? I want to make an image, load some image, like make a window, load some images, apply some like movement to those images or transform, so I can do like rotation, scale, and movement. Then I want to like start creating what could be like a save file that represents this thing, right? So a save file there, I can load it and say, take this image, apply this path, and like, or like apply this transform to that image or something. That could be like save state one, right? Then I want to see like, okay, let's start right trying to figure out how we can apply shaders to this thing and hook that into like up into the tree of stuff that we're trying to do. Then I want to try doing like a cut and a paste. Really, if we get to the point where we can do a cut and a paste and have that like saved into a file that gets like reapplied the next time we open the project, I think that's like a very, very good spot to get to for the day. So we'll see how far we get. But that is like the vision of the editor. I apologize that it's not really like, I haven't quite figured out how to explain all of the pieces that are in my head right now, but I'm hoping that it will become clearer as we move forward. Okay, so step one. Let's like fucking make a window. Right? We need to do something at all. So let's make a image editor. Sure, it's fine by me. And I guess we will start by copying a development environment from somewhere else. Let's see what's in here. We don't need Python, we don't need libz, we do need Zig. And I guess we'll probably do like glfw for our window initialization. And is it libgl here? Is that how I do this? Or like, is it just gl? I'll have to look it up. Next package search. Oops. No, I want the fucking, why? Give me the fucking actual, why? Oh my god, there's a fucking website for this. Where did it go? Here, I don't know why. Okay, jeez. Okay, libgl, is that what we're looking for? It's lib and then gl capitals. I'm not 100% sure that I want to commit to using OpenGL for everything here, because the OpenGL drivers under the hood could, there's like a possibility that they will behave differently, which means that's not really great. It might be better if I could do my own stuff CPU side from scratch. But I think that we can try to write our code in a way where we can make that decision later if we feel like it. In reality, it would be silly, I think, to do like fragment shaders all over the place without GPU acceleration. I think that it's probably better, but we'll see. Maybe we kind of like do GPU acceleration for a preview, and we do CPU things for like actual export or something. I'm not sure. We'll think about it later. Let's do a glfw getting started. I'm sure that they have some, I think they have a example program that we can just copy paste because we are too lazy to do this ourselves. So let's just start with their C example and try to turn this into something that resembles a simple hello world for us. So this thing, actually, before we do this, I want my environment to have Clang tools in it as well, so that I can jump to definition in C files. But this thing, I think that he essentially creates a rudimentary vertex and fragment shader, He initializes his glfw window and sets up the OpenGL context, creates a buffer to feed into the shader pipeline. He compiles the shader, his shader, sets up some vertex buffer attributes, and then like basically draws. So we should be able to see, like, I think this thing draws like a triangle. Let's just see. He's using GLAD as OpenGL loader. I think we don't need to do that. I think that we can get away with doing like a gl.h, and then there's like, I think you need glx prototypes. Yeah, you define this thing, and then you don't need to use a loader, which is cool for us. We don't have linmath, so fuck it. We'll delete it, and we'll just make sure that we don't have to try that hard. We'll just make sure that we don't use like try to do any like matrix manipulation here right now. We'll kind of handle that later. They have these types defined that we don't have, but we can kind of say fuck this vertex type. We'll just store our vertices as a flat list of 32-bit floats. And so if we want kind of these edges of a triangle here, I guess we'll kind of do something like this. I think that they have color in here as the other thing. We can store color as well. Fuck it. We'll store color. So this is 5 times 3, so 15. Okay. And then we'll just kind of like delete some curly braces here. Yeah. Something like this. Okay. So this has vertex, this has like corner positions of a triangle plus some color. They have a matrix that they're passing in. I'm just not going to do that because I think that's probably where their linmath stuff comes in. And then here they have color and fragment chilling. Okay. So now, fuck GLAD, we're not using that. And then here we just need to fix up the attribute stuff. So we made it so that we have each attribute. So here we are uploading the size of a vertex. So this is, I guess, the XY RGB times float size. So that's 4 times 5 for both of these. And then the vertex position is offset by 0. And the fragment shader position is offset by 8. 8 bytes, 2 floats. Okay. Then they do some like matrix multiplication stuff. Just fuck off, I don't want that. Fuck off, I don't want that. And I think that that should compile with link glfw and lgl. Okay. And then we've seen this before where we need glfw kind of like dynamically loads Wayland libraries if they're using like LDO or DL open, which means it needs to be able to find them. So I don't know how to like deal with this in Nix very easily, other than by just adding the path directly to LD library path. So we go like env grep Wayland, load project idea. Thanks. I'm excited about it. I think it'll be fun. So I think if we just run like test now, there we go. Okay. We have a window with a triangle. Now, I would like this to be in Zigland, so that, I'm just more comfortable there right now, and I think it's more fun. So can we could go through the work of converting this to Zig ourselves, but I would like to see if the idiot will help us here. How good is he? Who knows? Can you convert this to Zig code? Let's just see. I don't really know if it does this in all sane way, but okay, so he imports glfw, he imports gl, he sets the vertices as f32s, the shader text, I think he's fucked this up a little bit, but that's fine, we can clean that up. Error callback, he didn't write callconfc, but otherwise he did convert this into like a std debug print. This is wrong. This seems like okay. I mean, it's like probably closer than the C code. We can start here and see what happens. He sucks at Zig, I find. Yeah, that's fair. There's not like a ton. There's not. I guess the amount of stuff in the world or on the internet about Zig is probably smaller. But last time I did this, I remember not being quite happy with the amount of effort I had to put in to make it work. Okay, so this thing needs to be we'll kind of do this like this. Okay, vertex shader text, we can kind of get rid of these new lines that he's kind of throwing everywhere, and then all of this stuff should be kind of like this. Okay, that's looking a little better. Fragment shader text. I wonder if we're gonna regret this in a minute when we find out that he fucked something up in like a subtle way that I didn't notice. That's classic. Classic chat GPT idiot. So here we need to write call conv c. Same here. Okay, and then here he doesn't know that the language doesn't have double ampersands, but he did at least figure out that we can put these things behind like GLFW dots, which is kind of nice. Kind of nice. Return error, dude. He's so stupid. Error GLFW in it. This is create window. Okay. And then we're gonna have to be kind of careful about all of this stuff. Like, it's likely that he fucked this up. Int to pointer. He's close here. 8. It's pointer from int. Okay. It's actually not as bad as I thought this was gonna be, to be honest. Float from int. Boom, boom, boom. Okay. Oops. And then presumably he's gonna be like, oh, this isn't even used. I don't even need that, to be honest. Yeah, it's fine. Okay. Zig run source main zig. Let's just see how fucked up it is. Unused local constant 38. Yeah. So can we do like stud mem span of description and turn this into a C pointer like this? Okay, this is unused, this is unused, this is unused. Hi, I hope you're doing good. I want to know if you offer classes on Twitch, like maybe paying a certain amount of subs for a class. No. No, no, no. I am not. I am not here to educate you. I am here to have fun and maybe post it online if that's useful for anybody. But I'm not here to. My goal here in no way is to be your teacher. So I apologize, but you're gonna have to find that from somewhere else. Really impressed with the new Claude. I last time I looked, I think I had to log in, so I didn't use it. So I just don't use things that make me log in, which really limits the amount of stuff I can do. But it is what it is. So I think this thing is returning the old error callback, and we need to discard that. Same with key callback. And then this thing's mad because like I forgot to put a question mark somewhere here. This thing needs a question mark. And then root struct of C import has no GL gen buffers. Because here I think I need to do C define of GLX prototypes again. I think that's what I want. Something like this. I think it's void type, not null type. Nice. And then here we need to write const for this to work. Okay. We're getting close. Size of vertices. Okay, so what are we doing here? Here we're trying to upload vertices.len times 4 for 4 bytes per thing. Is he happy with the rest of it though? Vertex shader source. What does this thing want? Expected type double const C pointer, found triple const C pointer. Sure. And then here it's double const, double const. So I should just be able to pointer cast that and it should be fine. I don't really see why that would be a problem. Okay. And then here, we need to take whoever's using this and cast him, I guess. Is that what he's mad about? I think so. We will see. And then he wants it here as well, I guess. Which is annoying. I'm sure there's a better way, but for now, we will see. Segmentation fault, because we need to LC as well. I always forget to link libc. Then we need to do our LD library path thing. LC, LGLW, LGL. Okay. He didn't fuck it up as bad as I thought he would. I'm not gonna lie. The fact that we got the thing eventually, without too much work, like basically just syntax errors, is nicer. Nicer than I would have thought. Okay, sick. Okay, so we have a window. Let's try to load some images. Let's try to get something in them. So, in order to render a picture, we are going to basically want to, instead of doing a triangle here, can we do something that's like from negative 0.5? We want to do like a rectangle. Here's what I'm thinking, right? So we're gonna want like to get a rectangle and put an image on it, right? And so what we can do is we can do that as a triangle strip. So we want like here, this is one triangle, and then this is another triangle, which we can do as a triangle strip with 4 points. So we just need top left, top right. So 0.5, negative 0.5. Let's strip color for now. I don't think the color, well, we need to do like UV coordinates. So this is going to be UV of 0 to 0, 0, I guess. Then we're going to go top right, which has UV coordinates of 1, 0. We're going to go bottom left, which is 0.5 or negative 0.5 to 0.5. I guess I haven't really thought about if this is upside down or not, but you know, it's fine. Well, it'll become obvious in a minute. And this is 1, 1. Okay. Then this guy is going to take in a vec2 of UV, I guess. And he's going to export this thing as VUV, I guess. And this thing is going to be vec2 as well. Then I think that that's fine. We're going to have to adjust our vertices, our format specification here. So this is going to be 2 floats for the position, 2 floats for the UV coordinates, which means that this is 4 by 4 now for the stride. These things are 16 bytes away from each other instead of 20 bytes. And then I believe everything else kind of just works. We just have to make sure that our fragment shader is taking the... This thing shouldn't be called color. I think it should be called UV. And then we'll call this UV here. Okay, then we need to make our triangle strip. We want to draw GL triangle strip. And we want to draw 4 of them instead of 3. 4 points instead of 3 points. How's that looking? VPause location. So probably this thing is, he can't find VPause anymore, presumably because our shader compilation is just failing and the GLFW demo didn't like take that into account. So we probably need to do like, here, GL, what is it? Get shader if, and we look at the vertex shader and we're looking for a GL compile status or something, except this is called GL here. And then we want to put that into status, right? Okay, so then we go like if status is equal to, I think it's like CGL false. Then we have to like write return error vertex compilation failed. Let's just see if that kind of comes up. Yeah, so he is failing, which does make sense. And so then we do like Can we do like, we're gonna have to do this twice, once for the vertex shader and once for the fragment shader. So can we just do like check shader compilation, right? And here we'll like take in the shader, which I think is like a GLU int, probably. We're gonna be like, we're basically gonna call this, and we're gonna call it on shader, and this will be shader compilation failed. I guess we'll do if status equals GL true, we return. Then otherwise return false, because then we can do the rest of the stuff without being indented, which is kind of sick. It's like get shader info log, nice, from the shader into our buff size, I think it said. So we need like a buff, which is gonna be like, I don't know, 4K of U8 data. Whenever Zig's Spurvy backend matures, it might be interesting to check out a stream. There's been recent progress, but I don't know how close it is. Probably not very close. That sounds kind of interesting. So you're kind of saying that there's like a 3D API to Zig that I could use instead of all this. That sounds kind of interesting. For sure. I'll check it out on the next release, probably. This tells us how long we actually got. So len, that's a thing. So we have like, what's the type of this thing? GL size I. Var len is a GL or GL size I is equal to 0. And then the last thing is probably the buff address. Yeah, and then we can go stood log error, or yeah, error shader compilation failed for this reason, and we go from buff 0 to len. Okay. So now we can go back here and just say try check shader compilation for vertex shader. Get all this shit going away, and then we can check the same thing for the fragment shader. Okay. What do we fuck up? He's mad because this thing needs to be intcast. Fine, if you're gonna be like that. Okay, so value of type vec2 cannot be assigned to variable of type error. The fuck? What the fuck? So this is at line 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. 8, 1, maybe it's 1, 2, 3, 4. Oh, color doesn't exist. Oops. That would do it, huh? Now he is mad that vcall location is still no good. That's interesting. Maybe link status failed? Oh, wait, hold on. No, vcolor doesn't exist. That would do it. VUV location is VUV, and this is VUV location here and here. Nice. Okay, that's looking pretty good. So we're seeing like a rectangle in here that goes from 0, 0 in the bottom left to 1, 1 in the top right. Looking pretty chill, looking pretty chill. So I think the next thing to do would be to load an image and try to show it on this thing. So maybe we'll say that before that we had a chapter in here for like, render a quad. Okay. And now we are on 2832. Load an image. Okay. So we have been working on this PNG decoder, but I would prefer to kind of reduce the amount of shit that can go wrong right now. So let's just use a real image loading library because I don't want to fall over too hard. Let's do this. Okay, and STB image is going to come in here, and I think that importing in Zig doesn't really work quite right here with this type of like header. What works a little better is if we do STB image.c, and we do the like implementation import here, and then we compile this as part of our application. So, okay, then we go to here and we go STB image, you'll see import STB image .h, and now we have to like load the image. So can we say like, I don't know, man. Oopsies, what did I just do? What did I just do? Fuck. Let's do something that's like load image to texture. Okay, so we're gonna like get an image from some path. And I think that probably null terminating this path will work a little better because I think that stb image can take in a path. stbi load, yeah, okay. So this is kind of what we're gonna be doing. We're gonna be like, give me some data from this path. Var width is gonna be a, what does this take in? Int. Same with height. This tells us the width and height as its output. And it also tells us how many channels there were, but we say, fuck you, I don't care how many channels there were, just give me 4. I always want 4 channels. That makes my life easier. And then, so this will, I guess, return maybe some data. I guess this is going to be like a stb image who is going to have like a slice, a width, right? And then he's also going to have us, like, the reason we're doing this way is because our dinit function is going to just call stbi, was it like stb image free or something? Free, image free, yeah, here we go. I'm gonna call this. Okay, cool. Which I guess kind of means that this could be like this. Bum, 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 bum. Bum, 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 bum. Okay. And then if we load an image to a texture, we'll just say var image is equal to stb image init with path, right? And then defer as image dinit, boom. I guess this is probably const, and then this thing is to return a thing. So I guess we'll say if data is null, we have a fucking problemo, right? So return error no data. If width is less than 0, we have another problem. So we return error invalid width. Otherwise, we're fucking chilling, and we can just return our thing, which is going to have data of is from data from 0 to width times height times 4, right? Because we asked for 4 bytes per pixel, and our width is just going to be int cast of width. Boom. Chillin'. I agree partially with the title of your stream. I wouldn't go as far as replacing GIMP, but God, the UX is ass, even if GIMP cover a lot of ground. Yeah, I mean, it's tongue-in-cheek. It's not like I'm going to make something that's better than GIMP. I'm just going to make something that might be better than GIMP for me specifically. Right? It's kind of sick that when you can write software, you can just imagine something that you want and then it can exist. And that's so cool. You don't have to, and the only input is time. That's so sick. Like, it's not like I have to go to the store and buy a bunch of wood. It's just like I just sit down and start typing. It's pretty fun. Okay, so we should have this image now. Surely this doesn't even like compile. Well, I guess it probably will because it's dead code eliminating all of the interesting parts that we just wrote. So let's try to call, this thing is probably going to have to return GLUint, right? For the texture. And I guess we'll just write like unreachable. Suddenly I want to go to woodworking shop. I do feel like the same like worm in the brain that makes people want to work on their houses, I think is the same brain, the same worm that makes me want to write code. It's just like manifests in a very slightly different way. I believe that like I think there are like streams or like YouTube videos where you like, you know those like videos where you like watch a guy mow a lawn for like a couple hours and it's just like really satisfying to watch. I suspect that that's like very similar to watching this in a lot of ways. Maybe not exactly the same, but not that far off either. Yeah, also like the same as like Factorio gameplay. Yeah, it makes sense. It makes sense. Okay, so let's just try to load something like image PNG or something. Soap shaving? Yeah. I have both worms. Hell yeah, dude. Can we just look at like, I want like a landscape or something, just like a picture of something semi interesting. I want something that has like a good bisect of like sky to land because I think that will be kind of interesting later. So maybe we can do this. Maybe we can do this wallup.net. Okay, we just this is also kind of big. Can we like I kind of want something that's like a little bit smaller. There we go. Yeah, let's do this. That looks pretty good. Copy image link. So if we do like curl -o this, -o image.ping from this. Is this a PNG? It says PNG tree. Okay, there we go. Sick. We have something. Dude, that's so oversaturated. This doesn't look like. I guess maybe this is a drawing. That would make it make more sense. I can't tell. That image is AI 100%. Yeah, okay, maybe that makes more sense. Whatever, I don't give a shit. It doesn't matter. Uh, okay, so now he's mad because C import has no member named stbi load. That's true because I didn't import stb image.h. That's a good point. And then I also need to include source. And then expect type usize found cin 86. And I think that there's enough stuff going on here now that it makes sense for us to make a little build script. Because I don't want to keep having to type this, like, I don't want to keep typing this command. So we'll do function build, takes in a stud builder, which means that we need the standard library. Import stud. Okay. B, add executable. Root source file is source main zig. The name is going to be, what do we call this? Image editor. Target is from some target, and optimize comes from some optimization level. This creates an exe, which then we need to link libc. We need to add include path of source. We need to link system library of glfw and gl. And then what else is it? We need to add C source file. We need to compile the STB bindings as well. Like this. Okay. Target is B standard target options. And we need standard optimize options as well. Okay. Is that enough? Is that enough? No, because this needs to be a public function for the builder to be able to call it. Because I think what Zig does is it has like a build script and then it just like imports your build script and like compiles it into its thing and then calls the function. So if the function's not public, you can't call it. And it looks like this compiled, surprisingly. Oh, I forgot to install the artifact. B install artifact exe. Okay. So that should make a thing in Zig out, probably. Zig out bin thing. Yeah, okay. Zig build and run that thing. And we forgot to fucking set the LE library path. So Zig build and call this. Fuck. God damn it. Can we copy this and then do this with this? And then I think we might have to write env here. Okay, there we go. We're hitting our unreachable, which is good. Which is good. That means like everything's probably kind of worked. Theoretically. So we need to like create a texture of this thing. So can we be like is the idiot here to help us maybe? Is he still open? Can you give me some code to some C code to load an image texture from a buffer with RGBA? Pixel, yeah, pixel data for usage in an OpenGL shader. Let's just, I don't want to like fix. I know that like there's like, I can never remember. You need to set like mag filter and min filter, either like these. I always forget these. So this is pretty much what I want. Yeah, this is pretty much. I just always forget. Okay. I always forget. Don't make fun of me. It's too hard, man. So var texture is going to be a cgl uint equals 0. We call, it's not c, it's gl, right? And then it's gl dot here and here. This is texture, and we return texture here. Okay. All of this stuff gets some gl in front of it. Boom, 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 boom. Boom. And do these parameters look right? GL texture 2D. I don't remember what the 0 here is. Let's GL text image 2D. Let's just double check. Level, right? So magnification level 0, internal format, RGBA seems good. Width and height come from image width, image calc height. Then what's else in here? Border 0, I remember, and format is RGBA. This is the format of the data versus the backing storage format. And the input type is a uint, sure, or a uint data, and the data is just like image data pointer. Okay. I think I don't have to do this. Pretty sure. We'll see though. Okay, this is build. Probably not. Probably a bunch of like int casts and shit. Okay, so we need to try to create our image. That's true. Yeah, so I'm kind of surprised that this compiled before. But whatever. Okay, now what? What you doing, bro? I'm new here. We're making an image editor. Make an image editor. Read the stuff on the right. We leave it up so that you can catch up. I apologize it's small because there's just too much shit. It has to have, there's too much words today. Typically there's a little less. Okay. So now he's mad that this is like wrong, so we're just gonna incast this. What's the main reason you prefer Zig over C? I don't know if there's like a main reason. It's just I make less mistakes. There's like nice metaprogramming. Their standard library is better. Like you could argue that there is a standard library and there's not in C. There's just a lot. Yeah, it just feels kind of like if it C but newer and better. You know. Return self. The height is going to be the data len over self width, except that the width is in pixels. So we need to divide by 4, which is fine. We're kind of, it's fine. It's fine. Kind of shit code, but whatever. We'll live. Self data is mad because the dinit needs self data pointer. I'm surprised. I don't really understand how this compiled before. Because, yeah, it's like a fucking problem. Okay. Expected type any opaque found this. So can we just like incast this? Okay, and then oops, not incast, pointer cast. Hi, hello. Discards cons qualifier. I guess we can just store this as not cons, then it's fine. Kind of fix it itself. Okay. So are we chilling? Okay, so that loads okay. And then can we try to like apply that texture? So sample texture from fragment shader. I can never remember. Dun 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 dun. You know what? Fuck it. Does he give me the fragment shader in here? Oh yeah, hell yeah, he does. Okay. Hit me up, boy. Dude, have you guys worked with people? Fuck. Have you guys worked with people who do this? You write a comment. You write a comment that's just like, this is the thing that I just wrote. It's like, I can fucking figure that one out. I can figure that one out. So we'll sample from here with our UV, and then that should give us back out a vec4. So we can kind of go like this. And then I believe that my recollection here is that to bind a texture, you actually set a uniform value to be a texture slot, and then you have to bind the texture slot to the texture. So there's going to be something in here about GL active texture and GL bind texture, and then he should set the uniform for this thing. Does he set the uniform anywhere? No. But it might come for free, because the uniform, it might just automatically be 0 if we don't specify. That's possible. So let's see if this does enough, you know? It might. We could maybe dream. This goes here. He's mad because we go like this. That's not good. As far as I know, default 0 always, yeah. Also, hi, hello. What do you mean more comments always means better code? That's a really good point as well. Really good point. Okay. So this is where it gets tricky, because like, where the fuck have we gone wrong is like pretty unclear here. Let's try generating our bitmaps just in case. I don't really think that this is relevant, but it could be if for some reason it's like, yeah, it's not. Can we? It looks like we're compiling, so let's just make sure that like if we were to do something that was to go back to running vec4 1.0 1.0 or UV 0.0 1.0, is that okay? Like, we didn't like break it to the point. Yeah, so it's still doing something. Did I bind it to texture 2D? Maybe not. We could look a little more closely. Yeah, bind texture, GL texture 2D. Here we did bind texture, GL texture 2D. I don't really see a problem here. My suspicion is like this stuff. Seems likely that I forgot something. Let's look at OpenGL learn OpenGL textures. Maybe we should have looked here instead of the idiot. I do. Okay, so he sets GL linear here. He loads the thing, calls gen textures. He binds the texture. He uploads the texture. Okay. Then he puts the sampler in here like we did, and just calls bind texture here. He doesn't even say active texture, which is kind of surprising. Oh, here. Texture units. You probably wondered why this is a uniform, even though we didn't assign a value. Using GL uniform I, we can actually assign a location value to the texture sampler, so we can set multiple textures at once in a fragment shader. The default texture unit for a texture is 0, which is the default actual texture unit, so we don't actually need to assign location in the previous section. That's kind of my recollection of this too. That's my recollection of this too. So we call texture on texture text chord. Okay. Yeah, I don't really see a problem with anything that we did here. GL active texture, this. Texture comes from image, load image to texture. Did we do this too early? We might have forgot. We might have to do this after window context creation. That's actually pretty likely. Ah, there we go. There we go. Cool. Cool. Okay, so we have an image. Let's go. It's upside down, but fuck it, you know? Let's just, in our fragment shader, we'll just do uv.x and 1.0 minus uv.y. Chillin'. There we go. He's right side up. Let's go. Let's go. Let's go. Let's go. Let's go. The worst comments are for code that was deleted or changed. Dude, I've always said that the git commit log is for that. That's what git commits are for. You always put what changed in there, what you didn't do in your issue tracker, and why something is the way it is as the comments. That's always been my rule. Okay. So let's try to like move this thing around. So let's say that this thing that we are rendering is kind of represented by like an object, right? we'll kind of say that there's like an object in our world, and I think that we want to represent this object with as like a texture, right? So this is the texture ID of what this object represents, and I think that the object is going to basically apply some form of transform to the input, right? So this should be something that will represent like a scale, a rotation, a translation. We can kind of represent that all at once. In 2D, if you guys worked in like 3D before, you'll be familiar with like the 4x4 transform. In 2D, we can just kind of like drop a dimension. So we can say that our transform is like a it's gonna be a 3x3. So we can say like data is 9 f floats. And I think that maybe we should specify some like initial ones. So like identity is 9 f32s, which look like this. So const identity is this, and that's going to be like 1 0 0, and then with ones on the diagonal like this. Okay. Then we can say that this by default is identity. Cool. Are you going to be able to resize the window and maintain the image aspect ratio? I mean, eventually, one day, right? Because okay, so if your aspect ratio was like, say we fix everything to width, you can represent this is imagine this object by default takes up like the full screen, right? If you write 0.5 here, that will squish it down vertically in half, right? So we can encode the aspect ratio in this transform as well. So I'm not really worried about like handling that right now. I'm certain that in the future we will be able to handle that. I'm certain of it. Okay, so this guy's gonna have this transform, and we are gonna want to like upload this transform to the GPU. So can we just do something for now? Like, how do we want to handle this? I guess we're gonna have like objects, right? We're gonna have like a list of objects in our scene. Okay. Right. We need an allocator, I guess, huh? Var GPA is equal to std heap general purpose allocator defer GPA dinit, and we're gonna have to do something that's like const alloc is GPA allocator, the runtime generic interface out of this thing. Whoever took exclamation mark words per minute in chat is that's so funny. I like the idea that I would have written a command for you like this. I just think it's funny to think that would have come up enough and that I would want to brag about it enough to make a command for it. That's funny. It is like 100 to 140 depending on if you're like willing to accept errors or not. I spent a lot of time playing Type Racer in university. A lot. Okay. So where are we going now? So we're going to kind of go like for each object. I think that we're going to render the full object. So I think that here's what I'm imagining. We have our object. We'll now take up the whole screen. Fuck 0.5s, you know? Who needs 0.5s? You have 1.0s. And then we will just apply the transform here. So we're going to say like uniform mat 3x3 transform, I think. And then we can say that the vec3 transformed is going to be transform times the vec3 of v pos 1.0. Right? So in the same way that in 3D you have a 4-dimensional vector where you have homogeneous coordinates x, y, z, w, where w is like a divisor for x, y, z, you can kind of we have to do the same thing here because the w coordinate basically gets multiplied into the transformation matrix and can allow you to perform translations. That wouldn't work if you didn't use a vec3. Empty cup warning. No, it's still there's stuff in here. I can feel it. I'm not faking. But now we have to make sure that we handle the positions correctly here. So we need like transform.x here, transformed.y here, and then transform.z here instead of w. The divisor coordinate gets like moved over by one essentially when you move from like 2D to 3D this way. So now we need to like upload this transform somehow. So I think let's say for now this is default initialized. We'll kind of push an object here. So we'll say objects append, and we'll say that this is like, I don't know, we have a texture is equal to texture. Boom. Okay. So now we can say that like for objects, we have an object, and basically we're going to bind the texture from that object, right? And then we're going to do our drawing of that object like this. Boom. Simple, really. Really quite simple. But now we also have to apply the transform. So we need to find like the location of that transform. So we're going to be like transform location comes from transform, right? And then we are just going to have to like upload the uniform. So it's like GL uniform 3 by 3, matrix 3 by 3 FE or something? Matrix 3 FE? Yeah, that looks right. That looks right, okay. GL uniform matrix 3 FE. Let's see, what do the docs say? Okay. So 3 matrix 3 matrix here. So he takes a location, count, transpose, and values. The location is just transform location. Simple. Count is, I don't know. Transpose is true, I think, because it's a maybe C GL true, because I think that they store things in column major order. By the way, I understand why they do that now. I don't think I talked about this in like the GPU saga. But the reason that they store it like I naturally store the thing like this way, right? So like A, B, C, D, E, F, G, H, I, right? So I store things like going like row major, right? But OpenGL does it this way, which is really confusing. So they actually store this in memory as like A, D, G. But the reason they do that actually is like pretty smart. When we were looking at like the code compiled by Mesa for shader execution, they actually were doing this as like so like you multiply your x's by this column, your y's by this column, and your z's by this column, right? And what they ended up doing was they implemented this as like x's plus y's plus z's is how they multiplied this thing. And so if you store these things like in column major order, you can just multiply all of you can like take your thing and say like x, duplicate it 4 times, or 3 times in this case, and then multiply it by the column. And then do y, and multiply it by the second column, and z, and multiply by the third column, and then add these up. So it actually makes sense. It makes sense why they do it this way, which is kind of interesting. You are right that I did get attribute location instead of get uniform location. And then down here, I think we need the uniform data. So it's object transform dot data, and then the ampersand of this thing. Okay, and then I think count here might just be like specifies the number of matrices that are to be modified. This should be 1 if the target uniform variable is not an array. It's not an array, so 1. Okay, chillin'. Okay, so if we run this right now, what the fuck happens? Error unit is ignored. Shut the fuck up, little bitch. Sorry, that was aggressive. I didn't really. I could chill. Okay, so he's filling up the full screen. Pretty nice. Using, very important, to use escape or control C to insert to go to normal mode in Vim. Control C, or sorry, escape. I don't know why I fucking lied. It's like there's this piece of me that feels like a strong need to just lie. I have to fight it. I don't know. It's escape. I used to use JK, but then I found that I do this a lot, and then it was a problem. Are you caps control master race? Yeah, control is caps for sure. For sure. I don't like using the term master race though. That seems problematic. But I do like using caps as control. My wrists hurt sometimes, so it's helpful. Pinky's I played a way too much Fortnite, like years of too much Fortnite, and I had my edit key on tab, which felt really good at the time. So like, what's my pinky doing? But it turns out that in that game, you're literally spamming that button as fast as you can for like hours and hours and hours, and that just like fucked my wrists up. That was a PC Master Race joke that came up quickly. Apologies. No, I mean, I don't think that you meant it poorly. I just think that it's worth calling out that we shouldn't say it. Okay. So we have this thing. Like, can we try applying a transform to this thing? Let's say that we want to have some sort of scale, right? So this is going to take in nothing and return transform. I guess he's going to take in a x and y scale. So we're going to say like x and y. And we are just going to construct this thing. We're going to return x goes here, and y goes here. Simple. I don't know, man. It looks something like this. Something like this. So if then we say that our initial object transform is a transform.scale of 1.0, 0.5, we should see this guy kind of squish down in the y-axis. Yeah, nice. Okay, that's looking pretty good. And then eventually we can like start apply. We can like we can implement like matrix multiplication and stuff so that we can like compose these things together. But for now, this is kind of good enough. This kind of like tells me what I want to. This does what I want it to do for now. Okay, so let's. It would be maybe I should be able to like move the thing around. Let's do that. So we apply some transforms. Let's kind of say that we want to like move object around screen. I don't know if you guys can see that. I'll kind of like here. I want like the context to still be here. It's kind of annoying. Maybe this can come down a little bit. I guess you can make my camera. I could like crop my camera a little bit, huh? To give ourselves some more room. How do I do that? Alt click? Yeah. Okay, transition. Yeah, there we go. Better. Better. Now we can see more at once. Okay. What we're doing? Move object around screen. Okay, so we need to like interpret mouse movement in some way, shape, or form. And I don't really know how to do that. GLW mouse. Input guide. Okay. So we have key callback. We do have that. But what about mouse? Is mouse a key? Mouse. Looks like we set a cursor position callback. Okay, sure. Cursor callback and oopsies, this is what I want actually. My bad. Function returns void with call conf c. And we want a window, which is this thing. Xpause is, I guess, a F64. Ypause is also a F64. And this needs to come from GLW like this. Probably this is boring. Xpause and Ypause. Let's just start by std debug print. Xpause is this, and Ypause is this. Xpause, Ypause. There we go. Okay, and so this should be fix me camel case or Pascal case? Camel case, I think. camel case starts is the one with the lower first letter, I believe, but you know, whatever. And so can we just like GLW set cursor callback? Okay, let's start there and just kind of see how that looks. Okay, so it looks like this is in pixel space. Yeah, so this is in pixel space. So we need to convert this to image space, and then we also need to like apply, we have to like set this somewhere, right? So say I want to like click on this image and move him around. First of all, let's make him small. Like instead of being 1.0, 0.5, can make him 0.5, 0.5. Let's start there. Okay, so I want to be able to like click this thing and like move him, right? Which means that we have to know if like the mouse button is down. So do we have the mouse button in here somewhere? Do I see anything log right now? So when I press keys, we have keys and actions. Key, can we like print this thing? Like, if I do this, what about if I click? Clicking does nothing. So mouse button is probably different than mouse button is probably different. Oh, there's also input mode. Do I have the option of like screen relative? No, it's fine. Doesn't matter. Cursor, setting, enter, leave, mouse button, put here. I guess it's this. I guess it's this. If you say so. Call conv c void. We need to fix this, so this is the GLW window, button, action, mods. All right. We'll just start here with the button down. Button action, maybe? It probably press and release would be my guess here. Would be my guess. We will find out in a second. What's he pissed off about? Why is this wrong? Function, call conf c void. Oh, I got double embrace. Okay. So we probably have to do the same thing here, where we set the cursor pause, GLW set mouse pod callback. Okay. How's that working? Yeah, so press release, press release, press release. Got it. And now we have to like do something. So can we just be like a const app, I guess, is probably where this is going to start ending up. We're going to have like our objects are going to like live in the app. Actually, let's get status here. Let's like get everything in here. Let's let's checkpoint. You know. Yeah, okay. Whip initial commit checkpoint. Because I feel like we're about to start fucking shit up. So this is gonna have some objects in here. Probably an array list unmanaged. Makes more sense in this context. Can we make a functions like dinit, self is an app. Okay. Oh, non-codes, hello. Thank you for the raid. What's up, you guys? What is up? We are working on an image editor. We started 1 hour ago, so you're getting in early. Hold on, one sec, man, allocator. Does this compile right now? If it does, we can show it. Fuck. It does not compile because we just fucked shit up on purpose. One sec. Var objects is equal to std array. Oh wait, hold on. We just committed specifically for this. So here is our image editor. We have a picture in the middle of a screen. The idea behind the editor is we're trying to aim for something that has like a kind of like everything is implemented in terms of like shaders, right? So if I want to like cut this tree out, I will like draw a path around that tree. That path will be like an object in history that I can edit in the future. And there will be like the cut and paste action will be implemented as a turn path into mask, multiply mask by picture in shader, right? The idea here is that now the image with a thing removed is just an inversion of that mask. And if we want to do something crazy in there, that multiplication action is just a shader, and like the user will be able to like implement whatever shaders they want. So if you want to do a gradient from one side to the other, or like multiply the mask by the X position so that the mask is stronger on the right side or something, you can like do that if you want. And then if you want to go back in time and you want to like edit the path that was made to select the tree, everything downstream of that will just like happen automatically. That's kind of the plan. And so I'm kind of hoping that we can make like a very powerful editor with very little code, right? Because we're kind of like offload the work of actual image manipulation into shaders written by users, right? So if you want to do like a hue adjustment, that's just a shader that like does an HSV rotation. You want to do like, you want like a custom brush, you can write a shader that has like exponential fall off from distance to the path or something, right? That's the idea. We're on day one though, so we're just trying to move the picture around. That's where you guys came in. So thank you for the raid. Hope you all are having fun. And we're just gonna hop back in because we have a lot to do today. If we want to get to something sane, the goal for today is to get cut and paste working, which is ambitious. I admit it's ambitious, but possible. Possible, for sure. Okay, so this guy has objects. For now, let's just say that he's going to like take in an allocator on initialization and return to the app here. And for now, maybe we just hard code that we have our single object here. Right, so we can say that like const object is this, and we append this thing with our allocator like this. I guess we will take in the texture as well, which I guess we'll also hard code for now. Here, seems reasonable. And then we return our alloc is alloc and our objects is objects. Crazy stuff, crazy stuff. Now, that means that down here, instead of doing, we can just do like app init with our allocator. Boom. Probably variable app. And I guess if this is allocating in here, he needs to return an error, which means he needs to write try. And then here, this is going to be like, I guess all of this stuff kind of starts looking like a render function. Probably something like this. This is kind of like all of this, I guess. Sure. Width and height, where's that coming from? That's like the height and width of the window. So we just won't do that. That kind of solves that problem. This guy needs to store which program he's using, and he needs to look at his own set of objects now. So just throw some selfs around. Transform lock, I guess that's probably stored here as well. And the vertex array is probably also stored in here. I guess that kind of makes sense. Which means that like here we call app render, boom, and it means that we need to start like finding we need to like collect the information that we care about. I guess kind of like in app initialization almost. Kinda. So like, geez, I have so much code moving around. Okay. Compile, link, program. This is going to return a GLUint. And that's just going to, or not GL.GLUint. And that's going to be kind of, where's our like shader compilation section? Down here. Boom, boom, boom. Slap this down here. Where does program come from here as well? Yeah, return program. Okay. This thing can fail, which is chilling. So now const program is equal to compile link program, cut and paste over rectangular region. I think I want to do a arbitrary path. I think it's doable. I think it's doable. Oops. Because I don't think I want rectangular region to be a special case. I think I just want that to be part of like the generic path version, right? You could draw a path that is a square. Your tooling for interacting with paths could have a way for you to generate a perfect rectangle. But I think that we could probably implement it under the hood as like one simple thing, so or like the same thing. So okay, so this program, then we can like create the program in app initialization, maybe like here, as well as like bind all of this like this stuff here as well, and then here I guess we use on render we probably call GL use program here, kind of like this. That probably goes here or something. We'll just not clean anything up for now because I don't want to deal with it. Fix me app dnet. And then we just have to store the stuff we care about here, which is the transform location. And is that it? The program too, probably, right? CGL uint and the gl.gl uint. And then the transform location. Okay. So then we can save that stuff. Program is a program. Transform location is equal to transform location, which means that our render call can now use those things, and hopefully we compile. We don't. We never compile. Because I wrote const on the array list here. This thing probably needs to be variable. Defer. If we error out, we probably need to deinit that thing. It's a pretty good thing to be aware of. The program is mad because I put these in the object instead of the app. It's a hard life. And he wants cint for the texture. Or for the transform location. Nice. Error union is ignored on app render. Can this thing fail? No. So for now, we'll just take away the exclamation point. Just let the OS clean up. Yeah, exactly. He'll do it. Hopefully. No field named vertex array. So I guess we need to stash that as well. Fine by me. Anything else? He wants uint, I guess, which is again fine by me. All right, we're so back, baby. Okay, so now we have like a structure where we can start doing stuff in our like mouse callbacks, right? So what we want to do is we want to extract from the window. There's like GLW get user data or something, window user pointer. So I think that this will allow us to attach our application as a thing that it gives us back, right? So we say, yo, here's the window. I want my fucking app, right? So we want like app is a pointer to app, which comes from a pointer cast of this thing, right? And then here we can say like app select closest object, which is going to take in the X pause and Y pause, right? And that's all we got to do. That's all we got to do. Maybe this could like maybe fail, but maybe it won't. Who knows? Maybe she's born with it. Gotta stop with that. It's so fucking stupid. Okay. So here he takes in the app. He takes the X pause and the Y pause. And I guess now we need to store the width and height of the window for this to make sense, right? In order for us to be able to figure out which object is closest in like OpenGL coordinate space, we need to figure that out. So I guess we'll store like width and height, window width and height like this. And then we can say that the like we can do like a conversion here. Can we store this as this will be easier if we store it as F32s. So I want to do something that's like object chord or mouse chord is going to be like window to norm x pause y pause. And I think we're gonna try to stay in like OpenGL coordinate system, which says like we're working like -1 to 1. Window to clip, I guess we'll call it, because I think clip space is more correct here. And I guess this is going to take in self as well. Probably not, doesn't need to be mutable. And can we just return like this, I guess? I don't know. I don't give a shit. From the bottom left? Good question. I haven't thought about it. I don't know. Yeah, I'm actually not sure, which is kind of funny. So here we're gonna take the X pause. Can we do like floatcast here and here? I don't really need the 64 bits of precision. It's a lot. And we're just gonna be like self width, window width, X pause over this. This is gonna be this is gonna get the 0 to 1, right? So we want to go -0.5 times 2, right? Because to get it from -1 to 1. Okay, and we'll do the same for y. Okay. Okay, now what? Now what? I guess we iterate all the objects and we find their centers. So we go like for objects. We could even get a little crazy. We could define a less than function. God damn it. My indexer just broke. So we could define like a less than function, which defines itself as the distance of the center of the thing to the x coordinate. So let's say that we have like less than. What is like if we do like std mem min index of min, we're like iterating objects from self objects items, right? Then we can like figure out what does this index of take. No, he wants a std sort, I think is more argmin. Yeah, this is more what I want. So he takes in a less than function. And our context, I guess, is probably going to be like the mouse chord or something. Probably, huh? It's going to be like a context is type of mouse chord. I wonder if this is loud. It's kind of cool if it is. And the distance this thing is going to be like LHS center is going to be the like vector 3 of 0, 0, 0 applied to the object transform. Right? It's going to be like something like this. So this doesn't exist right now. And then we have to like take this and say like we have to like apply the homogeneous coordinate. which I don't know if there's like a word for. I'm sure there is, but we can call like apply to vec2, I guess we'll call it. Which means that we like need those types. So we need like vec3 is, I guess, vector 3 f32 or something. Is that kind of allowed? Is this the format? Yeah, length and element. Okay, yeah. So now this we need to do like function vec3 to maybe do like apply homogeneous. That kind of feels nice. So in vec3, return vec2, and what we just do like in 0 over in 2. Yeah. Like this. Boom, boom. Simple. And I guess then in reality, our like get mouse window to clip can just return a vec2. Like this. Cool. So then we can say, we need to implement this like transform multiplication. So we're gonna take in ourself. And then we're gonna say vec is a vec3. And he's gonna return a vec3, okay. So we're gonna go, how does this work? We multiply by row. Yes, we say self data 0 to 3. Can we do it like this? Is this like a thing we can do? Or do we have to like 0, 1 self data 2 like this? So this is times vec y z, right? 3. This might be a stupid way of implementing this, but it's fine. Arrays and vectors will chorus. Oh, hell yeah. So here I can just do self data 0 to 3 and 3, 6, 6, 9, right? You're kind of saying this will work. And then we need to like reduce these. So we need to like reduce. Is this how you like add? I want the reduce op to be add. Yeah, hell yeah. Okay, so then our return is kind of like this. So we return all of the components of x, then the components of y, and then the components of z. Nice. Yeah, hell yeah, dude. So I think that works. 0 to 3 dot star. I think. Oh, you think I have to do this? That would make sense because it has to know that it's a 3 array typed or something. That makes sense. Okay. So here I found the left-hand center, the right-hand center, by just taking coordinate 0 and slamming it in there. We need to go like apply homogeneous instead of going to vec2. Okay. And then here we kind of know that the context is a vec3, so I'm kind of okay with just writing vec3 like this. Then our context here is going to be the mouse coordinate. Oh, this is a vec2 actually. So this takes in context as mouse chord and less than function. Okay. So here we just say LHS center minus mouse chord. This is the mouse distance, the left hand distance, the right hand distance. Okay. And then what? We return LHS dist is less than RHS dist, except we can't do it this way because these are vec2s. So how do we like figure out we need to have like a length squared. So it's going to take in a vec2, right? And he's going to return a f32. and he's going to be like in times in, right? So that should do x squared plus y squared. And then we do reduce add, I think. Seems right. Length squared of this, length squared of this, and that should be fine. Except we want to use context here. There we go. And then here we wrote, all right, we need to write RHS like this. And so now we should be able to like stash that stuff. So we should be like selected object is a usize or something. I wonder if this mul compiles to an fmadd. That'd be kind of fun. That'd be kind of fun for sure. So here we just say self selected object is this, right? Now, for this to make for us to be able to test this, we need two objects. So we'll just make two. And now we need to make it so that as we drag the mouse, we need to like apply that movement, right? So how do we do that? Oops, this is supposed to be on mouse button callback. Oh, weird. Oh, that's not good. So when we need to say, we need to like, oh, this is gross. When the mouse button goes down, we have to be like app set mouse down. If button is equal to 0, gross. I hate this, but it's fine. And I think the button has to be, there's probably like GLFW, GLFW button, mouse button 1. And action is equal to C, it's like GLFW mouse down or something. Paul Kowalski, thank you for the 1 month. Thank you for the tier 1. Much appreciated. GLFW press. Then we're going to do something. Probably. They want mouse button left. Then we set the mouse down. Else set mouse up. And then here, I guess instead of saying select closest object, we're going to say like set mouse position, which is kind of nasty, but whatever. Okay, so here we're gonna like set mouse. Was it set mouse down? And then set mouse up. Long time YouTube watcher. Glad to catch you live. Glad to have you live. Glad to have you live. And then this is set mouse position, was it? So we called it? Yep. So this takes self as an app, X pause, F64, Y pause, F64. Okay. So here we need to kind of figure out when the mouse position moves, we're going to depend on if the selected, maybe we stash the mouse pause every time. Mouse pause window. Mouse pause. We'll call this. Okay. And we'll just kind of say here, can we just initialize this to something? It doesn't really matter, right? So kind of say like 0, 0 or something, right? Whatever, I don't give a shit. When the mouse position moves, we just set it. So we say in float cast X pause and Y pause. Okay. Seems reasonable. Then if there is a selected object, we need to like apply the movement. So here we're going to say like const movement is equal to, we're going to store the new pause as a vec2, right? of this stuff. We, at the end of this, defer that self mouse pause equals to new pause. But until then, we can use that as the movement. So you have like movement is equal to new pause minus self mouse pause, right? And if there's a selected object, we can look at self objects at that index. And for now, I want to say like obj.transform. Let's just assert for now that the transform at position 8 is equal to 1 because fix me implement matmul. I haven't done that yet, so I just want to like fucking heal the internals of the transform manually. So so we can look like obj transform data at position 0, 1, 2. This is the x. And at position 5, we add on the y movement. And we'll just fix me gross hack create a translation and matmul it in. This is fucking stupid, but it's fine for now. It is fine for now. So on set mouse down, we are going to select closest object. Here we actually don't need to do anything. In fact, all of this stuff can kind of just go directly in set mouse down. Fuck it, you know? We did forget to stash this thing as window to clip. So we can kind of do it like this. And then on set mouse scope, we just say self selected object is null. That's fine for now. This will work. Mouse chord here is now self dot mouse chord, mouse pause. You can always hope a helpful gremlin fixes your fixies for you while you sleep. Hell yeah, dude. He might. You never know. In reality, I will fix it later. It's just I need to prioritize what gets done in the stream, you know? Does this compile? Surely not. 269, I'm missing window width. I don't know, man. I don't know. Whatever. Yeah, whatever. I don't give a shit. Window width. Window height. Whatever. Doesn't fucking matter. Here, we'll just say like const width. Like this. Like this. Like this. We move the width here, the height here. And then this guy can take in window width and window height. And we'll just say fix me do something reasonable, like push width height into app. But for now, we're just not going to do that. Selected obj needs to start as null. True. Maybe we can call get window width. Yeah, we can. We can. I'm just not going to right now. Type comp time int, not a function. What the fuck? Expected 3 vector elements, found 1. Fuck. So it looks like we do have to... Oh, you're saying maybe it coerces like this? Maybe is what you meant earlier? I wasn't paying attention. We'll try that. Oh, that's kind of clever. That's kind of nice. Okay, so core dumped on pointer cast because we did never set the window pointer to be our app. So after we initialize our app, we kind of want to do this like off. We want to do this like as early as possible before we show the window. So I guess we can do it here. Here's fine. So we need to like set window user pointer, set window user pointer. Here we go. Okay. Uh, y-axis inverted, and it's definitely not selecting the closest thing, huh? Definitely not. So let's fix the y-axis here. Without understanding the the space at all. We're just gonna invert. Okay, so that's one thing tracking pretty well. Now, why is it always picking that one? That's a problem, right? So can we? I would like to debug this function. Uh, so I'm gonna run for a little bit first. Move this guy to the left, right? Just kind of like send him over here. Breakpoint on this, and then try to select this object. And why does this not work? So here we have our two inputs. LHS optimized out. That's fucking annoying. Okay. So that's a pretty good point. Pretty good point for sure. For sure, for sure, for sure, for sure. Okay. So, info, can we like breakpoint a little bit earlier? Can we breakpoint at 295? Okay. So here we have LHS. Okay. So the left-hand side is the smaller. This is the thing in the center of the screen. Then this thing we've moved over a little bit. Okay. Can we look at maybe if we step into this thing and then finish this? That returns 0, 0, 0, which makes sense for the left-hand side. Then when we apply homogeneous, we get negative nan, negative nan. So that's our problem. Oh, I guess that's true that these have to be 0, 0, 1. I'm just a dumbass. I'm just a dumbass. I'm just a dumbass. Ba, ba, ba. Yeah, that's looking pretty good. Right, it's not perfect, right? It's because it's picking based off of distance to center. So like if I pick like here, it's not really clear, but it's good enough. Good enough. That one felt odd. I would have thought that this wins here. Whoa, whoa, whoa. Oh, probably we're not doing absolute distance. No, something's not right here. So it was like we put this one here, we put... Yeah, why? This... Here, when I click here, it's picking the wrong one, right? If it's supposed to be going off distance to center... Yeah, what's going on here? Can we, like, I guess what we should do is we should run in GDB. Kind of find that test case here, like this. And then, oh, I need to get the thing in my clipboard. So we want to breakpoint here. So it's like here. This is... How did I get it wrong before? Is it like based off of this? Like it was like something like this was not working correctly. Am I stupid? How do we fucking... Oh, here we go. Here we go. If I click here, right here. No. uh, fuck. Oh, wait, we're fucking chilling. Here we go. Main.zig 294. Okay, so it's like right here. Okay, so do those look right? Maybe, right? So yeah, so these are just literally coming from the transforms. Okay. And then let's look at the left-hand side and right-hand side. I mean, those are numbers. I don't really know what I was expecting. Okay, hold on. So I just want to make sure, yeah, clicking right here and moving up down is not doing what I expect. So what are my objects here? Okay, we have like some objects here, right? Can we like dereference this twice? So we have one thing that's at negative 22 and one thing that's at negative 38, right? So the second guy, the thing at negative 38, is the problem. Like he's the one that's getting hit, right? Okay. So RHS negative 22, LHS negative 38. So left hand side is index 1. Okay. What's our like mouse position? Our mouse position is on the right. Hand wavy, right? We're on the right. So then can we look at the like if I do, yeah, I'm not allowed to do this. Okay, wait, hold on. Surely that's just broken, right? Yeah, okay. So we have LHS center. Okay, like whoa, whoa. Whoa. Context? LHS center? So how are we getting like this? Oh wait, okay. It just hadn't, okay, we haven't got there yet. Okay, so the distance here, we're seeing that we have, is this adding together? 82. That sounds right. And then this is subtracting his from this. Okay, so that also looks approximately correct. And then what does it return? 1.5. So can we do negative 0.82 times 0.82 plus 0.95? Ah, fuck. Get me out of here. Okay, 0.82 times 0.82 plus 0.95 times 0.95. 1.5. So that is, we're doing the right thing. Then what is the problem? So here we have something that is 0.66 and 0.14. Oh, the window's not square. The window's not square. That's probably the problem. So like y distance is like over compensated. So if we just set height here to 640, does it start to feel better? It probably does. That would be my bet. No. It could be that our like mouse coordinate conversion is also kind of wrong. It's very possible. Window to clip. X pause over width. Y pause over height. So this is 0 to 1. Forgot a bracket here. Forgot a bracket. No? Oh, wait. Okay, can we like log this? This is just a std debug print in to out. X pause, Y pause, new pause 0, new pause 1. All right, let's just kind of. How much are we fucking this up? Okay, well, a lot because we're not new lining, which is fucking annoying. Okay. So yeah, our Y position is like greater than 1. So we're doing something fucking stupid. Our X position seems correct, -1 to 1. Our Y position is going from like 3 to 1. So we're just idiots. Okay, 1.0 minus window height. There we go. Minus 0.5 times 2. 1.0 minus Y pause over window height minus 0.5. That feels kind of right, maybe? Yeah, that seems kind of more correct. There we go. We fucking got there. We got there. That feels a lot better. That feels pretty good. Okay. So I think maybe the last piece here is I want to do some sort of save and load. It would have been nice to get into like shader application and cut and paste. But I don't think we didn't get there. So instead, I think what I'm going to do is let's just try to make a save format. So because I think like what's important here is I want to make sure that we have our editor defined as a list of operations that can be reapplied later, right? So what I want to make sure is that if we were to hit save here, we would see, we would be able to open that thing up and like have these same transforms applied, which is a very simple thing to do for now. But I think that it sets the tone so that as we move forward, we'll have to keep that thing working, right? So for now, let's just say that like, I guess we'll save to a location. Okay. And we'll have a load as well. And we're gonna have to define some form of schema for this thing, right? So save data, I guess. And he's gonna have like a list of objects, I guess. Saved object, I guess. And what's a saved object look like? He's gonna have the transform. I think that's reasonable to like keep that in here. And he's also gonna have like the image source. Okay. Now, this thing is eventually going to be something that's like, he comes from like, he's either like from the file system, right? And if he's on the file system, then he's gonna have like basically a path, right? But he might come from some sort of like a shader application, right? And this is gonna be like, I come from some inputs, right? That's gonna have like object IDs or whatever, and then outputs is gonna have like something else. But for now, I think that we can just say that our image source is always gonna be const8, and we'll figure it out later. Okay. Which means that our object here needs to keep the source kind of like around, right? Otherwise, we won't know where he came from later. And this is kind of like, you know, like data for runtime. Like things that we can like recreate, but are kind of like trash. We can throw them out. It doesn't matter, right? So I guess we're gonna have to like construct this save data. So we're gonna go like, I don't know. We're gonna have some save data who is initialized with like self alloc. We're probably gonna just like immediately rip this shit away. Right, we're probably gonna do something like this. This is not an array list of save data. Sorry, this is a object saves. It's gonna be an array list of object save data, saved object like this. Nice. And we're just gonna basically be like, I guess we can probably init with capacity as well. We can take a guess. We'll be like, this thing probably has as many as we have objects. And by probably mean like fucking definitely. Right? What am I doing? Fucking objects items len. Which kind of means that like making this an array list is like unnecessary. We can make this as like self alloc of objects items len like this, right? And then be like var idx is equal to 0, and then we'll like increment this as we go, right? Self alloc free save object saves, which for some reason is auto completing. I don't know why. Feature request use AI. Okay, shut the fuck up. I can't even. You might be serious. It wouldn't be like that unreasonable, but also shut the fuck up. Your dash p, which I assume is like supposed to be the colon of your name, is the eyeballs, and the dash is his nose, and the p is his tongue down. I assume you're joking, but just in case you're not, fuck you. And if you are, fuck you too. I hope you can tell by tone that I'm not serious, but I feel like the need to say it because when you're on the internet, people can't tell. Okay. So I guess we're gonna be like 0 to self objects items len. We're gonna have to like serialize this object. We're gonna like object saves I is equal to self objects items I save. Maybe, right? I don't know. And we're just gonna be like transform is equal to transform, and source is equal to self source. And sure. Then we can just do like a stud JSON stringify. Of save data objects is equal to object saves, I guess. What else is in this thing? Just the objects. And like what else does this thing need? He needs like a stringify options. And like a writer, like where he's going. So I just need like an out f is stood fs current working directory create file of path, defer close of that thing. We probably need to try opening this thing. I demand AI. Yeah, of course we demand AI. Shut the fuck up. Should make the UI subscription based too. Oh my god, I hate you all. I don't really know how I'm supposed to format this, but whatever I did is wrong. Maybe that looks a little better. Okay, so is that it? Probably. On load, we're gonna be like const in file is std fs current working directory open file. Defer in f close, surely, and then we need to do like std JSON parse from token source, I think. And then this thing needs to take in a scanner or a std JSON reader. So std reader calls std JSON reader, and then this lets me, yeah, I think this takes in like in f reader and var JSON reader is equal to this, probably with like, I don't know, alloc probably. Maybe I wonder if we can do, maybe we do this like this. Yeah, fuck it. Fuck it. Now you're trying to use Zig as much as possible, but I've used SQLite in the past for a save format. It worked great. I would edit my save history with any. I don't think that I don't think I need SQLite here. I can see what, like, I think in some cases it works. It's very good. I just am not sure. I'm convinced that this is one of those cases. I know JSON's kind of shit, right? So I'm not really like, I might not use JSON long term, but I believe that like some sort of tree structure is like fine. Yeah, I'm not sure. It's not like there's like tons of data, but maybe there will be tons of data later. I'm not really sure. Does this thing not have a D in it? Does this thing not? Oh, this can't fail. And then does it have a D in it? He does. Okay. Okay. Then we parse from token source into a save data, and we take in an allocator and our scanner or reader, which is JSON reader. Okay, and then what else? Options, which I think I don't give a fuck. Okay. Then we will probably DNet this thing later. And then I guess we just have to go for like 4 parsed value objects. Saved object. I think we have to like construct a new object out of this thing. So I wonder if we can go like from save. Oopsies. Maybe here. Load. Okay. And I think we need an allocator here as well, because we have like the source needs to be cloned, because this is going to go away later. Yeah. Because the source that's getting passed in here is part of like the JSON object that's going to be deallocated later. So we need to go like transform, so saved object, transform, and then source is equal to mem copy. So I guess we need to like alloc const source is alloc saved object image source len. Yep. Sure. Then we mem copy from source saved objects image source. Okay. Then probably we do like an error defer alloc free source probably, and then like I think we need to open the image too, right? We like load image to texture, so we pass in the source here, which means that our sources actually have to be they need to be like null terminated, kind of. I mean, yeah, fine. So we can do like a dupe z, which can take in this, which means that we don't have to do this, and then we can load image texture from source like this. Nice. And then we can store source and texture is equal to texture like this. Seems reasonable to me. Seems reasonable to me. And then we can do like object load from saved object with self alloc. Error defer object dinit. Probably. I don't know. I'm kind of assuming that like we need to remove like clean up texture. If it's the last one, if we clean up texture, are we ref counting? Is it shared between objects? Who knows? Okay. But we can free the source at least. That's good enough for now. Which means that here, oops, we can say error defer object t init with our allocator, and then we can go like, we need like a new array list of objects. Something like this. Okay. I don't know. Something along these lines. Adam Learns Live, thanks for the raid. What's up, you guys? What is up? I hope you guys had fun over there. We are working on an image editor. We are on day 1. We are on hour 2 of this thing. And apologies for those of you who've heard the ramble already, but we do have to say it again because there's a lot of new people that should hear. We are basically trying to take something that we are trying to make something that represents a edited image like in GIMP, but as a series of transformations. Those transformations, I want them to be able to be edited so that you can like go back in time and say like, if I select something as part of like a copy paste, I want to make a path, turn that path into a mask, and then apply that mask to something. That's like how you would do a cut, right? I want to be able to go back and change the original path and have all of the downstream operations automatically get propagated. And I want to be able to then customize behaviors. So like say I have like a mask in a selection. What if I want to make that mask gradient from like not applied at the left hand of the screen, but very applied at the right hand of the screen? If we could allow the user of this application, me, the only user, to basically write custom shaders for any application, that opens up the door for a lot of like complex behavior that is implemented in a very simple way from the application side, right? You can do like a hue shift by letting the user write a shader that does like HSV color rotation. You can implement a brush as a shader that takes in the distance to like the closest point on a path. You can implement like you can implement like gradients as something that takes in like the UV coordinates and maps them, right? You can do color select as something that looks for proximity to color in the shader and it creates a mask based off that. There's like all sorts of stuff that you can do with relatively simple application logic. So that's what we're working on. We just got to the point today where we can open images and move them around on the screen. That's about where we're at right now. Have you checked Graphite? It looks like we were describing, but not quick enough. It's not fun to look at to see if it exists. I don't really care if it exists. I'm just trying to make something that I want. And making the thing is half the fun. So I have not looked into it. Although many people have suggested it. And so what you're walking in on right now is we are trying to design our save format right now. So basically we have like objects and they have transforms applied to them, and we're just trying to like write those down so we can load them back later. So that's what we're looking at. So our new objects, they come from a list of saved objects. And so I guess what we're gonna have to do is really like new objects, append object. Wow, crazy. Okay. With our allocator probably. Fix me pre-jack length. It's fine, we need like initial capacity. Sounds cool. Out of curiosity, once you're done, what would you use it for practically? Um, okay, so I've been running through gamer tags recently. One of my recent ones was Slurpee Banister. Cersei Lannister holding a Slurpee sitting on a banister, right? So I want to be able to composite a picture of a Slurpee that I got on the internet with Cersei Lannister that I got from the internet sitting on a banister that I got from the internet. All the lighting's gonna be different between all of them, and like sitting on a banister. Fuck, I missed part of the. I missed a joke in there, right? So like things you use GIMP for, right? So like thumbnails, gamertag jokes. That's pretty much all I ever use it for. Either jokes or thumbnails. So that type of shit. That type of shit. Another one another recent one was Slamwise Bamney, and there I wanted a hobbit with a really 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 big knee. And I like trying to warp a cartoon image that I got from the internet was like, I just found it difficult. Just like the idea of like, you have a picture of a guy, like I made an AI generated image of like the Hobbit with like his leg like stuck out, right? And I wanted to like bend the knee and stuff. And so like just trying to do stuff like that where you like maybe fill in the background, warp the image, that type of shit. I want something that like works well for that as well. So let's see. Holy shit, my frame rate's low. Oh, I guess because I didn't turn on the lights today. God damn it. How bad is it? Like, is that distracting for you guys? It's gonna be distracting for me later, but what you gonna do? I can't fix it. Can't change the past. I'm sitting in like the fucking dark. That's so funny. Okay, so I'm thinking here that we unconditionally de-init the new objects, which is confusing. But we were going to swap in old objects for cleanup on success. And I think that we have to go through every single one of the objects that we have. So for new objects, we have an object. And we just have to call object dinit with self-alloc, right? Which probably means that this needs to be like type pointer, and this needs to be items like this, okay? And then here at the end will be like stud mem swap. This. From new objects and self objects. Boom. I think that'll do it. Okay. So we'll make it so that when we hit Control S, I guess we should save. So we can kind of do this and say, if key is equal to glw key S, and I'm assuming one of these things is like modifiers. Key callback. Here we go. Mods is the last one. The last one. So modifiers here. And I guess it's like modifiers. I would assume it's like this and glfw mod glfw modifier mod control. Hell yeah. So hit Control S. We call app save to save.json. Okay. And then let's just say that if can we just like say like if I guess we can just like app.load save.json, and then just if it doesn't exist, we'll just say debug print no save smile. Okay. Here we need to apply, like take the source here on both of these, otherwise we lose it. And then expected bool and found cint. Fuck off, man. Okay, fine. Oopsies, what the fuck did I just do? There we go. Okay, so this we need to say, and this is not equal to 0. Fine. If you're gonna fucking be like that. If you're gonna be like that. Stood log error, failed to save, and in reality, we should like log y and backtrace, but I'm not gonna do that. Realizing you're just sitting in the dark is such a classic computer user experience. Yeah, that's not bad. Classic. So stringify error unit is north 340. This needs to write try. What else is he bitching about? He's got some expected object found error on objects in the load loop. That's probably here. Okay, what else is Matt? What else is he bitching about, this guy? This little whiner. Dupe Z does in fact need a U to know what he is duplicating. So this is a bunch of U8s, I guess. Okay, D init is mad because we need to pass in our allocator here. And then no field name source in 254. Yeah. Because we didn't match the names for some fucking reason. I don't know. Don't ask me. Okay, so here there's no save. We kind of move these things around, hit save, control, quit, run. And then he's seg faulting, which is super sick. Okay, so when we load this thing, de-initing our existing guys is a problem. Why did we fuck that up? I'm actually not sure. Not sure. Main object de-init. Oh, because we need to duplicate the initial things that we passed in. Have compile time strings, which is a problem. These need to be like this, or else he can't de-init them later. All right, that's looking pretty good. So I move these over, I close it without saving, run it again. They're in the old spots, and then here I move them over here, hit save, close, run it again. That's pretty fucking sick. That's pretty fucking sick. Happy with that. I think that's good progress for the day. I was hoping it would have been cool if we got to the point where we could like mask stuff off. But this is plenty good enough for now. I'm pretty happy with that. And I think that probably like we could get a little crazy here. And I think that if we can like hack our save now, if we go like, if we image search image, hear me out. And we say image to JPEG, right? Like we should be able to go into and hack our save now. And we should be able to load from image 2 on one of these. And we should see that like reflected here, except he didn't like that for some reason. Wait, why not? No save. All right, well, what if we go back here? So he's happy like that. He just doesn't like if I open image 2 for some reason. I thought that would have worked. Is it corrupted? Oh, it is just a JPEG, huh? That would do it. There we go. Yeah, looking good. Looking good. Hit save, close, open. Yeah, that's looking pretty good. All right, pretty happy with that. So, cool. Thanks for watching, guys. I hope that you enjoyed what you saw. I'm pretty excited about this project. I think that we're going to go... Like, we've got... Like, this is a lot of progress for one day, I think. That's pretty sick. I'm excited to see where it goes. I think it'll be fun. I hope you guys enjoyed watching. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 4:20 Pacific time now. So if you're watching live, anywhere between 3 hours ago and around now is when you would expect to see us live. If you're watching on YouTube, you might say 12:30 to 4. That's longer than the 2-hour VOD I'm watching. That is because we segment the stream into what we call happy hour and the main stream. Happy hour is kind of like focusing on we left the code in a bad state today, right? If we were to like just continue on like this forever, it would become unmanageable, right? So happy hour is kind of about like trying to take what we did in like prototype mode and turn it into something that is like not embarrassing as fuck to commit. So it's stuff like that. Maybe doing some research, maybe doing some like small projects that aren't worth their own stream, that type of shit. So if you want to see that, and you're watching on YouTube, you either have to catch us live at 12:30 to 2, or they're archived on Patreon and YouTube member streams, so you can check those out if you want. Code for this will be on GitHub eventually, but not right this second. We have to do a couple cleanup streams before they get there. But yeah, we'll be back at this tomorrow. We'll be back at this tomorrow. So thanks for watching, guys. YouTube, peace out, and Twitch, let's find someone to raid.